So this will be, okay, I'm muted. This will be the final presentation of the morning session for today, which is the certification and testing. So some introduction actually was made by Rafael regarding the 5G readiness tests, but you will see that the 5GASP is more than that, and it awards a certificate when some network application also follows some specifications. So what I have already introduced in the previous presentation is the vertical deployment model. We bring it up again here because I would like to revise that the testing is so essential so as to close this CI/CD loop at 5GASP, that the testing artifact itself, or the testing that enables, the entity that enables the testing, is a part of the so-called triplet. So the test descriptor is the third entity of the triplet, and it's also the final and the third and the final step of the CI/CD circle of 5GASP, which is the test execution. Again, the test comes forward, of course, after the slice preparation is ready, slice preparation is in place, and the network application is being deployed. So this is hopefully it can be visible even in the room. So at the right, you can see the high level, let's say, architecture of 5GASP. So the green box, the biggest entity of this is 5GASP nodes. This is a single entry point that someone uses to design the triplet and order and execute it. And the highlighted area is where the testing comes into place. So the highlighted area starts with nodes that initiates the testing process, while communicated with the testing entity, the testing, let's say, master entity, which is the CI/CD service. So the testing process at its whole span is overviewed by this CI/CD service. And this is the service that notifies nodes that the services, the underlying tests have been executed, successfully performed, so as to continue with the pipeline, which normally it is the certification, the exposure at the 5GASP marketplace. The testing itself, though, it is performed and executed at the Evolve facility or facilities where the application is being deployed. The results are being reported back to the CI/CD service. This is why this is the master entity of testing. And these results are being forwarded to the 5GASP nodes, closing this testing circle, so they can be available towards the developer, so as to have a first evaluation of what went wrong or well, respectively. And of course, signify actually the next step, which would be the certification. As we have a spoiler here, so we'll starting with the testing because the testing is what actually leads to a certificate. So zooming in to the test components, again, we have the master entity, which is the CI/CD service. We tend to call it CI/CD manager in 5GASP terms. And this is a service that actually oversees the respective testing entities at each testbed. It can trigger specific test execution at the respective testbeds, and also incorporates the test results visualization dashboard that is a list of the test executed, and is a list that is then fed to the certification entity to check which tests leads to specific certifications. The second part of the test environment is the facility itself, where the test is being executed. And as you can see, it comprises of the orchestrators, which are essential for deploying the application or even some tests. So the orchestrators can be the typical NFVO orchestrators or Kubernetes, as we have it today. So the network application is deployed on top of them. There is a test execution engine, which comprises of Jenkins along with the robot framework, which is a quite common testing framework that actually executes the tests based on the test descriptor that is provided by the CI/CD service. And there are some supplementary testing tools like the NEF emulator that we have just seen and the traffic controller. We'll see more of them in depth in the next slides. So 5GASP incorporates two kinds of tests. The developer-defined tests, and as the name suggests, are the tests that are provided by the developer to be run against the deployed network application. Of course, they're not actually referred here because they are not contributing towards certification. Because as someone can understand, the self-testing is not a means of certifying anything. So this is the reason that only the 5GASP defined tests are being showcased here. So these tests are following specific axes, as you can see, 4 axes in particular. So there are the 5G readiness tests that we have seen that come forward through the NEF emulator employment in the testbeds. And these tests evaluate the network application readiness to interact with the 5G components, namely the NEF, which is the core entity of interaction with the 5G system when we talk about an external entity. There are the security and privacy tests that determines the network application security and privacy levels through specific 3GPP security recommendation, typical penetration testing, etc. There is another axis, which is the performance scalability, and as the name suggests, it evaluates the ability of the network application to maintain specific performance characteristics in forms of KPI, for example, specific latency, specific throughput, etc. And the last axis is the availability and continuity, which determines the capability of the network application to sustain service over time when some extraordinary circumstances actually happen in the testbed or in the communication channel. These circumstances could be the application of bit error rating, specific throughput restrictions, latency restrictions, etc. What 5GASP is fond of is that all these tests, or at least the tests that have been developed within 5GASP regarding these 4 axes, are available through our open test repository, which is accessible through GitHub. It's also an open repository, so a public repository, so someone could not need to even be included in the 5GASP organization. And this repository offers some tests on each axis. So it offers 7 actually 5G readiness tests, 5 security and privacy tests, 11 performance scalability tests, and 5 availability and continuity tests, along with the scripts that someone would need to execute so as to test a deployed network application in a local environment and execute all these tests per axis or all of them together. So this is an open repository that someone could access even today and try to run these tests following the documentation and the scripts incorporated there, and verify that each application is compatible towards the tests that 5GASP introduced. So all these tests are being materialized by specific test setups in the 5GASP. The typical test setup is this one, showcased here, which comprises of the CI/CD service, as we've said, as a master entity that triggers the test execution. The testbed itself that comprises only of the cloud resources, NFVO or Kubernetes, and the test execution engine, namely a Jenkins instance and a robot framework instance as well. At this specific test setup, as you can see in the figure at the right side of the screen, the network application is considered the passive element because the flow initiates by the test execution engine that triggers a robot test to be run against this network application. The network application does not interact with these scripts, and the test results are being aggregated and reported back to the test execution engine that comprises an HTML test report output, as the robot does, and forwards it towards the CI/CD service. The second test setup is somehow different because it also incorporates a testing tool in the employed testbed, which is the NEF emulator. So it follows the exact same setup as before regarding cloud resources and the test execution engine, but this testbed also incorporates the NEF emulator so as to run some 5G readiness tests. The difference with this is that when the test execution engine triggers the respective tests towards the network application, the network application here needs to be an active component because it has to incorporate a block of code so as to interact with the NEF emulator as you have seen previously. So it has to offer a specific northbound interface so the test execution engine can trigger specific interactions with the NEF. And once these interactions are being performed, then this reporting API, as was introduced in the previous presentation, captures these requests and validates towards the test execution engine that these interactions actually happen and the tests were successfully performed. And the most complex setup would involve an NEF emulator and also a traffic controller. And by traffic controller, we wanted to have an entity that would employ specific traffic restriction with a deterministic way. So this setup comes forward for the availability and continuity test. The difference with the previous setup is that the test execution engine, again, will trigger the network application to interact with the 5G system via NEF. And this is, let's say, the down part of the screen or the bottom part of the screen that the application, again, interacts with the NEF via an included piece of code. But now the control plane message doesn't only comes back to the network application, but also is being forwarded to the traffic controller so as to impose some specific network restrictions. So this is a synchronization of the control plane of the NEF emulator with the data plane where this specific entity receives the same message as the network application. And when this happens, it enforces some specific data plane restrictions like bit error rate, bandwidth restriction, latency restriction to the data path of the network application, also testing this side of the application itself. Again, the restrictions and this interaction is being monitored by the reporting API, which validates that this interaction actually happened. And the test execution engine, when this happens, validates through a health check probe that the network application sustained these restrictions and could also overcome them and continue its functionality. Only then the successful test report is being generated. Specifically, as we had a brief introduction in the previous presentation, specifically regarding 5G interaction of the network applications, we have seen that the developers are actually familiar with the software design tools and the software design principles of their network application, but of their application. But to consider it a network application, it has to interact with the 5G system. This is where the providers or the developers coming for a strictly software work could not actually comprehend the need or comprehend the standardization efforts towards this specific goal. So this is where the mini API, the testing mini API was introduced as a part of the 5GAS testing platform. So this is incorporated in the network application VNF or CNF. So it supports both VM-based network application and cloud-native ones. So it sits on top of this specific, let's say, application component, the respective VNF or CNF that interacts with the NEF, and offers a northbound API towards the test entity to trigger specific NEF interactions. And as you can see in this diagram, let's say there is a specific 5G interaction test. that will trigger this test through the Mini API that sits on top of the network application through a specific 5GASP, let's say, de facto standard API. So as, for example, trigger the first 5G readiness test, which is the authentication. Then the network application will execute this command and report back to the employed, let's say, test. So this is how 5GASP managed to bridge the gap between the software development world and the 5G world regarding 5G readiness. So coming to the end, I mean, towards testing, this is another, let's say, dashboard or another functionality the central CI/CD entity offers, the CI/CD manager, namely the test results visualization dashboard. So when the tests or the bundle of tests are executed, this dashboard is being populated with the test results and also the test process stages. So this dashboard is available through a link after the successful performing of the tests, and comprises of the network application ID, which is unique for each specific application, the facility name, so we would verify that specific application was tested towards a specific facility, of course, timestamps and status of each test execution, the testing process stages, because the test could fail even prior to the test execution itself, but it can fail at stages, for example, that which are the environment preparation. The performed test list, of course, as you can see in the screen, and each tests that are being presented here can offer a specific unique discrete test log and report. So someone can actually reference to see what went wrong in the specific test. So coming to the certification. So after a testing is concluded, the typical circle of 5GASP is that the certification or the 5GASP certification would initiate. So this certification was introduced so as to provide a quick assessment of the designed network application regarding the 5G features and capability of this application in diverse environments prior to, for example, deploying this application to a costly operator environment and coming forward and seeing specific bugs or 5G features not working there. So the certification process actually follows principles from third-party operators as well. So it can easily be replicated in their environment. So I had the merit of having incorporated some big corporations in our project. So they brought forward their certification process, namely VMware and Orange. So this process can be incorporated or replicated by their ecosystem as well. The process is mostly automated and controlled by the 5GASP nodes. So we employ a somehow zero-touch, let's say, principle here, because we don't want human intervention within the 5GASP process. And what we foresee to have is all the applications that have actually successfully passed the certification to be showcased under the 5GASP marketplace under the respective certified category. So the reason that we have introduced tests before certification is because the testing under circumstances or conditions leads to the certification. So for a certificate to be valid or certificate to be issued, all the mandatory tests per axis needs to be executed. We will see about them in the next slide. And also all the conditional tests of this axis should be performed as well. The conditional test derives from the test profile that each network application needs to apply to. So we have introduced several test profiles, and let's go one by one. I mean, there are self-explanatory, but the first one would be the application layer traffic. It seems that These are the applications that are relying heavily on application traffic. The data plane application, the deployment type of the application, VM or container, the location or mobility-based application, the application that needs to support NEF interaction, a premium quality of service application, and an application that is scalable either on the number of the application instances or the number of users. So each application needs to select some specific profiles so that the conditional tests would need to be executed prior to the certificate awarding. Going towards the certificate itself, the certification process offers a grading. So each access will have a score. The score comprises of mandatory, again, and the combination of mandatory and conditional tests. And if all the mandatory tests per access are successful, then one access score is being awarded. This access score is the bare minimum that someone needs to have so as to be, let's say, awarded a certificate on this specific access. It goes without saying that every mandatory test needs to be performed and successfully passed so as to award the minimum certificate. Also, the grading is further supplemented by the conditional tests, where they contribute towards the X score via their weighted average. So when it comes to testing, and you can see the spider diagram in the right side of the screen, that is supplemented by the table that has specific score per axis. I'm not sure that this is quite distinguishable, but they have some numbers towards 10, as it seems from the chart. The certificate grades could be awarded as well. So we start with the bronze certificate. The bronze certificate implies that we have the minimum, let's say, requirements met, which is only the mandatory tests. The silver certificate that would require a minimum of 5 per employed testing access, and the gold certificate that is awarded if all the employed access score above 8. The certificate itself is being presented in this slide. So, of course, it incorporates the certificate grading, which is something that an application would be fond of, the network application name, and along with the network application vendor, of course, the applied test conditions so as to see which of the tests should be referred as conditionals and mandatory, the respective access score, of course, and the performed test list along with their result. As you can see, for this specific certificate, for example, it is awarded as gold, but a specific test failed. Again, the gold certificate can be awarded if the test access can have a score above 8. So this specific test is one of many in the security and privacy access. So it doesn't actually undermine the overall score of 8. Last but not least, when we have a successful certificate award, what FiveCasp offers is the certified network application marketplace, which is modeled via the product entity of TM Forum that we have referenced in the previous presentation. And this specific, let's say, placeholder holds the network application itself. It holds a link to the certificate and the validation from FiveCasp that this application underwent the certificate program of FiveCasp. And this application or this card, as it can be seen in the screen, comprises of the network application name, vendor, and version, the certificate link, and markdown description that can be anything from links, pictures, figures, or graphs, and a link that actually directs the specific application to direct the user to the deployment environment of the specific application. And that would conclude this presentation, and I'll be happy to answer any questions.
Thank you.